Okay, in this video we are going to look into short circuit protection. So we're going to do some circuit design. Now on my breadboard I have an Arduino Nano which will be driving my beeper and my LED on and off. And I'm using a 2 transistor driver. This is my universal relay driver which I made a video of. So I could activate it. You can see the beeper and LED come on. And it's being driven by the Arduino Nano. Now if my beeper or my LED shorts out, it's going to draw excess current through my drivers, my PNP driver, and it could damage it. So in this video we're going to look how we could protect our driving circuit from short circuits. So I'll play a clip of how the universal relay driver circuit works. Then we'll look into how we can make it short circuit proof. Okay, here's the schematic diagram of the relay driver circuit, which I built on my breadboard. Now it's powered by 5 volts because we're running a 5 volt relay. And here's my 2 transistors, the 2N3904, which is an NPN, and my 2N3906, which is a PNP. And here's my 2 inputs, input number 1, which is my active high input, and input number 2, which is my active low input. So if we feed a voltage into input number 1, either 5 volts or 3.3 volts from the GPIO from the microcontroller, it'll turn on the NPN transistor, which will pull the collector to ground. Now when the collector gets pulled to ground, it will cause base current to flow in the PNP transistor from VCC to the emitter base junction through the 3.9 k ohm resistor and then to ground. Now this small base current flowing through the PNP transistor will cause a large collector current to flow through the PNP transistor, which will energize the relay, will turn on the relay. So the PNP transistor is a source driver, so we're switching the high side. So when the PNP transistor comes on, it energizes the relay, and it turns on the LED indicating drive to the relay coil. Okay, so now you know how my 2 transistor driver interface works. But instead of driving a relay, I'm driving a beeper and an LED so you could actually hear it. Now I've added 2 diodes to my circuit to make it short circuit proof. And I have a wire connected to my ground, you can see it down here. Now I could ground out the load, the beeper. So I'll turn on the circuit. If I ground out the beeper, you can see the beeper has been grounded out, and you can still see my Arduino Nano pin 13 still driving my interface circuit. And if I release the ground, it's still going to work, so that means my transistor was protected. And I'll do it again. So we'll have a look at the schematic. How I added 2 diodes. It's a very inexpensive fix to make this circuit short circuit proof. Okay, here's my 2 transistor driving circuit, and the load I'm driving is a beeper instead of a relay. So when the Arduino Nano feeds 5 volt pulses from the GPIO pin 13 into the first transistor, it's going to drive the second transistor as a high side switcher, which will feed the load 5 volts. Now if we short out the load, our beeper, this point here, if we short this to ground and we turn on the transistor, we're going to have current from the 5 volt supply through the transistor directly to the ground, and will exceed the current rating of the PNP transistor and will destroy the transistor. So by using 2 diodes, by adding 2 diodes to the circuit, we can make this circuit short circuit proof. Okay, here's my 2 transistor driver circuit with 2 diodes added to the circuit to make it short circuit proof. And here's the 2 diodes. They're 1N4148 switching diodes. So now when the load gets shorted, so this point here gets shorted to ground, so the cathode of this diode will be at ground level, ground potential. So when the microcontroller goes high to 5 volts, so it'll be 0.6 volts dropped across this diode. So there'll be 0.6 volts at this point here. Now with 0.6 volts at this point here, it's going to be just enough voltage to turn on this diode, but not enough voltage to turn on the transistor. So this diode eats away the 0.6 volts across this diode, and it keeps this transistor from coming on. So this turns off, which turns off the drive to the second transistor, which turns off the drive to the load. So every time we get a short on the load between here and ground, it will feed back into the first transistor and shut this one off, which will shut off the second transistor and protect it. So that's how we make the circuit short circuit proof. Okay, so that's my solution to make my driver circuit short circuit proof. It's very simple, just uses 2 switching diodes, very inexpensive. Now I use this circuit a lot for voltage translation. with our logic levels going from 5 volts down to 3.3 volts. Now we're going to see 1.8 volts and even 0.8 volts in the future. So I use this a lot, so it's handy when it's short circuit proof.